This video is going to be slightly different from the previous videos I've created for the Design a CPU 2 course. Now, as it stands, the videos that I've created so far on YouTube are not necessarily the finished version for the course that I'm creating. I'm actually building this up as I go along, and I'm learning the best ways of doing things. So I'm using these YouTube videos as a kind of learning process. And whenever the final version of the CPU is finished, I will then go back and redo and regenerate it as a course. So having said that, it allows us to be more kind of informal about these videos, and I can just show you my thought processes, and I'll show you not only what I've done, but what I intend to do over the next couple of days or so. So having said that, at the end of the last video, I mentioned that we really wanted to take the extra positions here in the counter and use those so that we can generate more complicated instructions. And the first thing I did was, in order to test to see whether we actually want to take the instruction, the set enables out of the ROM or not, we were going to have to test and see whether we're in a fetch or the execute cycle. So in the previous version, we tested on the execute, so we would have the lines coming out 4, 5, and 6 through an OR gate. But of course, if I'm going to have 16 positions here, I'd have to have like all these positions coming down into like a 16 input or whatever OR gate. But I could do it the other way around about. We could just put it in through the fetch. So if we take the first 3 from the fetch and put it through a NOR gate, it'll do exactly the same. Okay, so that's the first little thing. Now, the other thing I mentioned in the previous video was that I wanted to just use a simple counter in order to count the positions in the ROM. Okay, so the instruction that would come in, the instruction would give us the base position for that instruction, and then we would count through a potential of another 16 positions for the rest of that instruction. And I wanted to do it with a little counter. So I actually envisaged just a setup that we have here at the moment. Now, I never managed to get this built. Timothy Morgan last night got in front of me, so he's been in and built that, and it works perfectly fine, and it was really just what I had envisaged. And it's just a little counter that's going to count through the 16 steps. So it takes step 3 as in effect as a reset or a start position, and once it hits step 3, it then just starts counting through up to 16, and then we just add up. We add that on to the original 4 bits of the instruction. So in effect now what we're going to have here is now an 8-bit address. So we're going to have 2 to the power of 8, which is 256 values. Now, there's 2 things I want to look at today. The first one, which I'll just talk over quickly, and then I'll get back to this, okay? The first one is this little section here. So this little section is the jump if command. Now, it still uses position 6 within the stepper. Okay, so position 6 is an input to this. And I really want to try and get rid of this position 6, because we want to just replace all these other steps with just that simple counter that we have shown you below. Okay. So that's one thing I'm going to have a little look at today. I don't know how easy or difficult it is to do that, but that's something that I'd like to get done. Now, the second thing I want to do, and it's something that's a lot more interesting, and that is that even though I've got 256 positions here now within this ROM, it doesn't really help me, because the positions that we've got in the ROM are just extra positions on the the instruction set that already exists. So let me explain that. The ROM here, we can split it into two. We can split it into the columns. The columns are just the original positions of the stepper. So this is column here is like stepper position 4, 5, 6, 7, 8, 9, 10. So these are the stepper positions, okay? So the vertical lines of our control unit. And the horizontal positions here are our instructions, okay? So we get the horizontal position here from these 4 bits, and we get the vertical position from the 4 bits from our counter. So that's how we generate this matrix here. But the problem that we have here is that what I really want to do is we want to take the instructions here, and we don't want to place them just down one below another. We want to actually just place the instructions, one instruction in one set of addresses, and then take the next instruction and place it in the next set of addresses, and then the next instruction in the next set. So if we can do that, it would mean that we could take all of the instructions here and we can place them in a very, very small area within that ROM. And then it would leave space available for extra and more complicated instructions. But then we have this interesting scenario where if we use the actual instruction here and the value of the instruction just to point to that address, okay, so that an ALU would have a particular instruction. I think it's well, I can't remember the actual instruction, but it's going to have a 4-bit instruction opcode, and we're going to be pointing to that. We're going to be pointing to a particular address in the ROM, and that would be the start address. But that would mean that if we were to say, for example, change this so that it was maybe a 10-bit address, or a 12-bit address, or a 16-bit address, then we would be taking these values and they would be positioned kind of randomly throughout the ROM. And we don't really want that. I want to try and keep them all together so that we can keep as much of space free and available to us for more commands. So it would mean that in order for us to do this, we would have to change the opcodes for our instructions. So we would have to have an opcode that began at position 0 here within the ROM, and then let's say it was an ALU instruction, so that would be column 4, 5, 6, and then there would be a stop command, so that would take up 4 positions. But then we would want to place the next instruction just at the next address. And if it was, say, an exclusive OR, then again it would be position 4, 5, 6, and then it would be the stop, okay? So this would give us a method of placing all of the instructions just one after the other and allowing some space for extra instructions. But then if we were to rewrite this instruction set like that, it would mean that if we were to generate, say, an assembler, right, the assembler we would generate, it would be just like, it would appear to us to be just very random, as if we've picked random numbers for each of the instructions. Now, it wouldn't actually be like that. We'd have picked them for a particular reason, and the particular reason is that we want to get them to sit in the ROM properly. But as a programmer, you don't really want to know these details. So what we could do is we could keep the assembler exactly as it is, and then whenever you write your assembly language program, what would happen is whenever it got converted into your actual machine code, it would have a little lookup, and it would look up the actual instruction that you're going to put into the machine, and the actual instruction you're going to put into the machine is different from what you've got with your assembly language. And it's different because you want to position it in the most efficient manner within that ROM. So quite difficult to explain, but hopefully you can understand the root thought what I'm talking about. But that's what I'm trying to do today. Okay, so those two things I'm looking at today to try and upgrade and get this thing, close to finished. Now, by close to finished, what I mean is it's not an actual finished article, but it means that if we go to extend it or expand it in any way, if we go to put in more complicated instructions, or if we go to add in extra registers within the CPU, then we can do it quite simply. We don't have to be running wires all over the place. It can be a quite easy, simple fix, and that's really the point which we want to get to within the next couple of days. So a bit of a rambling video, a bit different, so thank you for listening. I'll get you on the next video. Goodbye.